Okay, guys, we are live. All right, so let's begin. Hello, everyone, and in this video, we'll be learning about circular queue data structure. So it's actually a queue data structure which we have learned in the last video, but it's a bit different. So you would say that yeah, logic is same, but some are differences which we'll see. Okay, so what's the difference between a normal queue and a circular queue? So a normal queue is actually a straight stack, you can say a straight stack of memory. Okay, you can say yeah, we have some limitations in a queue definitely, so we can consider it as a straight stack of plate. And now if I talk about circular queue, circular queue simply means that things are aligned in a form of ring. Okay, so it simply means that if one thing is empty, the other thing will take new element will take the place of a ring, and it's like that. So we'll see what's actually the method which we'll be using for circular queue, but mostly you'll be dealing with arrays or linked lists for creating a circular queue always. Okay, so let's begin. So before proceeding further, in the live chat you will find a link of a course provided by Geeks for Geeks. So if you visit that link, and you'll find the same link in the description. So if you visit that link, it's about a course which is for DSA in JavaScript. So you can check out this course, and if you wanna become a great web developer, then obviously you would be needing some tools like this. Okay, so you'll always need some extra edge over everyone. So a lot of people just ignore DSA, like it's only for competitive programming or else stuff like that, but DS is a very useful concept. And if you learn all the data structures and all the algorithms, like most important algorithms, then definitely it would be really helpful in your development journey. And especially if you are a backend developer, then you would need to build some complex logics in the backend part, so you would always need efficiency. For that you can use these kind of data structures and algorithms, and you can see that everything is mentioned here. So if it's not only about web development, if I talk generally about competitive programming or any kind of programming, or you're doing web development or app development, you would always need DSA concepts, because these concepts actually build up your mind. Okay, so you can check out this course. This is a paid course. All right, so let's continue. So now let's begin with the definition of circular data structure. Then we will understand it by just viewing with an example. Okay, we'll create an example out of it. Okay, I'll show you how things are added. Same enqueue and dequeue operations are performed in circular data structure also, but the difference will be seen later on. Okay, so let's continue. So first of all, definition. Let's begin with the definition. So a circular data structure, circular queue data structure, is also known as a circular buffer. It is the data structure that represents a queue or a buffer in which the endpoints wrap around at the beginning. So in a regular queue, when a new element is added and the queue is full, and in general, in a regular queue, when a new element is added and if the queue is full, further additions are not possible. But some elements, if are removed, then you can add elements at the end. Okay, but however, in a circular queue, when the end of the queue is reached, that means the circle is reached to the end. Suppose you have five positions in a circle, five position in a ring. Suppose the fifth position reaches, then again you can start from the first position. It's like that: 1 2 3 4 5, 1 2 3 4 5, just like a clock. After 12, what you see is 1. Okay, again after 1 2 3 4 5 6 7 8 9 10 11 12, after 12 you again see 1. Okay, so it's like that. You can assume queue as that. Okay, circular queue as that kind of format, a clock format. Okay, so also it is used in clocks also. So yeah, a circular queue can be implemented using an array, and it can also be implemented using a linked list. And in a circular queue, when the end queue is reached, new elements can be inserted at the beginning of the space if it's available. As I told you, you can insert after 12. 1 o'clock is there. Okay, again 1 2 3 4 5 6 7 8 9 10 11 12, again after 12 1 o'clock is there. So it's like that, same in queue. Okay, so now it has two types of pointers, basically a front pointer and a rear pointer. So front pointer simply keeps track of that thing which is about to be removed. Okay, simple. And rear is that thing which is the latest element which you have added to the queue. Very basic. Okay, so when elements are dequeued or removed, the front pointer is incremented by 1. Okay, that means we'll see that the logic for that. But yeah, just remember this trick. Whenever you are dequeuing any circular queue data structure, the front pointer is incremented, and whenever you are enqueuing the circular data structure, then it simply means that the rear pointer is incremented. Okay, so when dequeuing, we simply increment the front pointer, and enqueuing when enqueuing we simply increment the rear pointer. Okay, in dequeue we increment the front pointer, and in enqueue we increment the rear pointer. It's very basic knowledge. So yeah, we'll see that. And then circular queues have various applications and can be used in situations where we have a fixed buffer size, like a clock. Okay, after 12 you won't be having 13 14 15 16 in a general clock. So you can actually use a circular queue data structure, that is after 12 one will be there. Okay, so very basic example. And other example is you can actually use it for CPU scheduling. That is, in operating system, circular queues can be used to manage the execution of processes or tasks in a round robin scheduling system. So when each process is get a fixed quantum of time when they are preempted. Okay, and another example of data streaming. So if you are watching anything on Netflix, data comes in a stream format. Okay, circular queues are actually useful for managing data streams in real-time system, such as audio or video coming from a source, where a fixed size buffer is used to hold that incoming data. When you have watched that buffer, next data comes. It's like that. Okay, so whenever you have watched that data, it's not like a whole video of 1.4 GB or 10 GB comes at once. Okay, it's not like that. A very small chunk of video comes and it's stored in your buffer, in your device buffer from Netflix server. Okay, so again, if you have watched that part, then the new data comes and again stored in the same buffer. It's like that. So again, circular queue data structure is useful here, and it saves a lot of memory. That's why it's beneficial. Okay, so if you have a memory limitation, like you can't just get a 1.4 GB of video at once. So if you have memory limitation, you can actually use circular data structure. Okay, so we have also used in it in a printer. Okay, so if I talk about a printer, if you have very limited files, like about 10 file size, like I talk about, you have a PDF and you want to print thousands of pages. Okay, so it's very difficult for the printer. So for that, a circular queue data structure is actually used. And what it does is, first it remembers the order of the first few pages, then again the next few pages. It's like that. So it's again some limited memory, but the pages are changed again and again. Okay, so I hope you're connecting with me. And then we have one more example is network packet buffering. So circular queues are utilized in network routers or switches to buffer incoming network packets. Okay, so actually data comes in form of packets, that is so you have seen that 1 Mbps speed, 2 Mbps speed. So it's actually meaning that yeah, data can be maximum of this size. Okay, it comes in form of packets, then they are merged together. So these packets are actually repetitively coming and saved again and again and again and again. So it's like a buffer, and you can also call it a circular queue data structure usage. Okay, so overall circular queue data structure is providing an efficient way to manage data in scenarios where we have a fixed buffer or a fixed size or a memory limitation. Okay, so it's very useful data structure. So now let's learn this. Okay, so here we have just given some basic application. Now we'll just learn this, how actually it works. Okay, so you can see some other videos on YouTube, but there is no proper explanation how actually things are incremented or decremented in front and rear pointers of a circular queue data structure. So we'll be understanding that in depth, then we'll be writing code for it, because coding part is very easy, understanding it is difficult. Okay, if you understand this for the first time, you can watch the code for 10 times anytime you want. Okay, so if you know the logic, you can watch code anytime. All right, so let's continue. So now I'll be writing the JavaScript code for this. But before JavaScript code, I'll explain you how circular queue increment, that is enqueue and dequeue, work in this way. Okay, so let's open whiteboard and I'll explain you there. Fine. All right. Hmm. Okay, so let's first see that yeah, I don't like this white background, so let's change the background. Okay, yeah, something nice. No, dark is fine. All right. Hmm. Then we'll choose a format background. Okay, fine. So now we'll be creating a circular queue, and circular queue is, you can assume it like some ring. Okay, some like ring. Okay, so let's create a ring out of it. So I'll assume that my max capacity max capacity is actually, right now I'll just assume it as 5. Okay, let's assume it as 5. You can have a more memory size, but right now we'll just say that yeah, my memory size is 5. I can store 5 elements at a time. Okay, at a time. So for that we can actually use circular queue logic, and it's very easy actually. Okay, so let's say we have a ring here. Okay, we have a ring here, and I'll just draw it once and then we can use it again and again. All right, so 1. Okay, so 2, 3, 4, 5. Okay, I hope this looks good, and let's connect them with some line. All right, so you can assume it as my circular queue. Okay, so it's fair enough. Now what we'll do is we'll start with the first operation which we'll always do in any circular queue, which is enqueue. Okay, enqueue. First of all, we'll be performing enqueue here. So what I'll do is, first of all, I'll just copy this so that we can use this again and again. Okay, so I'll just copy this. Okay, so copy this. All right. So now what to do is we'll be starting with enqueue. Okay, so let's say first operation is enqueue. Fine. Hmm. So let's say we have elements, we have to store elements 10, 20, 30, 40, 50, 60, 70. And you can see that the maximum capacity is 5. That means we can store these much elements at a time. Okay, then when this 10 will be removed, then next element will be stored, then the next element will be stored, like that. Okay, so that's how actually things will be working here. So let's understand, if I talk about a normal queue, if I talk about a very normal queue, so let's draw a normal queue. Okay, so I'll write here normal queue, and this is actually a circular queue. Okay, circular queue. All right, fine. So normal queue actually has a very straight line. Okay, a very straight memory line. And actually what happens is, first of all, you will be inserting 10 here, right? You will be inserting 10 here, then you will be inserting 20 here. So obviously in a normal queue also you won't be having an infinite memory. You can always store some few elements only. Okay, so the problem with this is actually, here you can see, I'll just tell you the difference here. Okay, so here you can actually see that first of all, this element is going to be removed, right? This element is going to be removed. So we'll actually call it as front. Whatever element is going to be removed is known as front, and whatever is the latest element is known as rear. Okay, rear. That's it. That's the logic for normal queue. And it's the same logic for our circular queue. Okay, so let's write things inside the circular queue. So let's assume that this is the starting point. Okay, this is the starting point. So I'll just highlight it with this. Okay, I'll just assume that this is the starting point. And initially, I would say that my front, I'll just write my front variable here. Okay, so front is equal to, initially it will be -1. Okay, that means it won't be pointing anywhere. And similarly, rear equals -1. Fine, initially they will be -1. So first of all, I'll insert 10 here. Okay, first of all, I'll insert 10 here. So what would happen is front will be incremented. Okay, front will be incremented. So front will be actually incremented for the very first time. That means if front is -1, then you are going to increment front. Okay, I'll just say that if front is -1 equals -1, then just increment it. Okay, that means it is going to be incremented for only the first time. Then the front won't be incremented. So now your front is actually equal to, I'll just say f is actually equal to 1. Okay, f is actually equal to 0. That is the 0th index. Okay, so now what I would say is instead of this 1, front will actually become 0 because we have inserted 10. Okay, that means front will become -1 plus 1, that is 0. Okay, so front will become 0. And again, you also need to increment rear every time you add an element. Rear, just add rear every time you add an element. Okay, so what I'll do is now what will happen to this is initially you added 10, so rear will actually become 0. Okay, now what would happen? Now if you add another element, suppose you added 20, so what must happen is you would always increment rear whenever you add element, right? So now what would happen is you would increment rear whenever you are adding an element. Okay, so now what I will do is I'll simply increment rear. Okay, fine. Again, if I add an element, suppose I add 30 here, so what would happen is I would simply say that increment rear again, so again rear will become 2 this time. Okay, rear will become 2 this time, and you can see front is not changing because we are not removing any element. Okay, we haven't dequeued right now, we are just enqueuing again and again. Okay, so again rear is incremented again if I add 40 here and if I add 50 here. Okay, so now the rear will actually become 4. Okay, that is from 0, 1, 2, 3 and 4, that is the fifth element. Okay, that is the fifth element. So it's actually starting from 0 and its maximum value can be actually 4. Okay, after 4 you can actually see we don't have any space remaining, right? We don't have any space remaining. So now what to do? So what actually happens is after this, if you perform any dequeue operation, then the next rear will be actually shifted to again 0. That it's like that. Okay, so now let's do that. If I perform dequeue operation after this, so it's very easy, just the same logic. So what I'll do is I'll just perform dequeue here. Okay, fine. So yeah, it's fine. So again what I'll do is I'll just paste things here. Okay, I'll just paste things here, and now let's assume the same scenario. We have elements here 50, 10, 20, 30, 40. Fine, fine. So now here you can see again if I write what's the condition here? The status is actually front is right now 0. Okay, that is this is the front. Okay, and then you would say that the rear is actually now 4. Okay, rear is actually 4. So I would just say that rear is actually 4. Rear is pointing here. Okay, so I would just point rear with this blue marker so that it's easier. Okay, and it's pointing at fourth element. Okay, so you would say that this is the 0th element, second element, third element. Okay, sorry, first element, second element, third element, and fourth element. Okay, so right now you would say that rear is actually pointed at the fourth element. Rear is pointing at the fourth element, right? So after this, we can't actually increase it. Okay, we can't increase it because after fourth index, we don't have any index, right? So now what would happen is if I perform a dequeue operation, okay, if I perform a dequeue operation, I remove 10. I remove 10. So what would happen is, so let's write dequeue here first of all. So here we are dequeuing. Okay, let's perform dequeue here. So now we are performing dequeue operation. So what would happen is you would say that this 10 will be removed, right? This 10 will be removed. Now what do you need is you would simply say now your front will be incremented. Okay, your front will be incremented. That means 20 will become the new front. Okay, front 20 becomes the new front. That's it. And the value of this front would actually now become 1. Okay, front it will become 1. Okay, initially it was 0, now front will become 1 because you have performed the dequeue operation. Okay, dequeue works like that. Again, if you remove this 20, if you remove this 20 at any time, you don't need the queue to be full. Okay, for dequeuing you don't need to you don't need this complete values to be filled. Okay, you can perform dequeue at any time. I'm just telling that whenever you perform a dequeue, front will be incremented. Okay, now you can see that again you remove 20. So what would happen is now front will be actually here. This will be the front. Okay, this will be the front. Again, if you remove this 30, okay, and one more thing, front will be incremented. That is now it will become 2. Okay, again you will say that let's remove this, and I'll just remove this. Fine. And again you will say that the front will be incremented here. Okay, front, and yeah, now its value will become 3. Talent. Okay, without erasing I actually change the values. Okay, so yeah, front will now become 3. So now you can see again if I remove this, again if I remove this, what would happen is next time the front will actually point to this 50. Okay, that is front will become this. And now you can see that at times front and rear can actually be equal. Okay, there you can't just say that yeah, front and rear will always be different or they will always be equal. At times then they can be equal, at times they can be different. So now you can see front is also 4, rear is also 4. Okay, so now after this, suppose you want to add an element, and you can see that I am at the last position. Okay, 4 is actually the last position. So now if you want to add another element, okay, so you can see that what was our stack, what our stack was actually 10, 20, 30, 40, 50, 60, 70, right? So these two values are supposed remaining. So what would happen is now if you add 60 here, so 60 will be actually added here and rear will be pointing to 0. Okay, so now this rear will be pointing to 0. Rear was 4, rear was 4. Once rear reaches the last value, next time rear will become 0. Okay, that will be the logic. So once rear reaches the last value, now if you try to again add new value, rear must be incremented. But since rear is in the last value, so what would happen is you would simply make it 0. Okay, if this value is 0th value is empty, then you will be only able to add values. Okay, that must be cared. Okay, so now you can see that now rear is actually equal to 0. And what is front? Front is still 50. Okay, front is still 50. That means front is still at index 4. Okay, so I hope you're getting this. That's how things actually work. So now again, if you remove this, if you perform a dequeue operation here, suppose before inserting 70, I actually performed a dequeue operation. What would happen is now the front will become, this will become the front. Okay, this will become the front. And now you can actually see that again, front and rear are the same. That's it. Okay, so now suppose if I again add 70 here, again add 70 here, so 70 will be actually added here, and now this will become the rear. This will become the rear, and rear will be actually incremented. Rear will actually be incremented. Okay, so this is very basic logic. Whenever you are enqueuing, rear is incremented, and whenever you are dequeuing, rear isn't doing anything. You are just incrementing the front. Okay, whenever you are dequeuing, you are incrementing the front. Whenever you are enqueuing, you are incrementing the rear. That's it. Okay, so now you can see that yeah, yeah, it's fine. Okay, so you can see again the front is here, rear is here, and rear is actually now pointing at 1. Okay, it's not pointing at 0 anymore, it's pointing at 1. and yeah, front was actually pointing at 0. Okay, so things are actually working like that. So I hope you understood the basic knowledge of how it actually works, and I would. Okay, so now I would tell you how you can write code for that. So very basic, and now we'll be writing code for that. But before one more thing, I'll just write the conditions which are important here. Okay, which were important here. So let's write that. Okay, so first of all, initially what would happen is front is set to -1, rear is set to -1. Okay, you need to make sure this initially whenever you are declaring a circular queue, these things will be -1 and -1. Now what would happen is if you are adding, if you are enqueuing, okay, enqueue, in enqueue operation, what would happen is rear will be incremented, rear plus plus. Okay, that means if it's -1, it will become 0. 0 say 1, 1 to 2, 2 to 3, 2, 3 to 4, and 4 to again 0. Okay, if the capacity is 5, that is 0 to 4. All right, so yeah, it's fine. And one more thing, one more condition is for enqueuing is if you are adding the element for the first time, that means front is -1. Okay, if you are adding element for the first time, front is actually -1, front equals -1, you would simply increment front here. Okay, front would be incremented, front plus plus, that's it, very easy. Okay, and again same for the dequeue. For the dequeue operation, what you are doing is obviously you are adding the elements also, you are adding the element to your array also. Okay, adding element, whatever element you are inserting. Okay, element will be inserted and rear will be incremented and front will also be incremented. If front is equal to -1, it will become 0 for the first case. Okay, now what would happen is if you are performing dequeue, what would happen is front plus plus. Okay, front plus plus, and in dequeue operation you are actually incrementing the front. Okay, incrementing the front until when, until you have elements in your array. Okay, so it's very basic, you don't need to write those conditions. If it's empty, if it's full, you can understand that, right? But yeah, in dequeue we actually increment it. And one more thing is there in the enqueue part. So what I'll do is I'll just change its position. Okay, fine, right. Okay, so yeah, one more condition is actually there, and suppose rear reaches the last element. Okay, so I would say that if rear reaches the last element equals rear is actually previously at the last element and you have performed enqueue, what must happen is it must point to 0 then. Okay, last element is 4, 0, 1, 2, 3, 4, last index is 4, after that it will point to 0. So here you would say that if it's pointing at the array dot length, suppose your array is containing all the elements, array dot length -1, which is actually, if you have 5 elements, it will be giving you four indexes, right? So yeah, array length -1. So if it's the case, then you would say that rear equals to 0. Okay, set rear as 0. Okay, I hope you got this. And this is a very basic operation which we are going to again write in JavaScript for the same circular queue data structure. Okay, so these conditions are very important and we'll be writing that. All right, so now let's continue. We'll be writing it in JavaScript. So I'll just save it first and then we'll be writing it JavaScript. Okay guys, so this was the code which we have written previously. You can see in the last video we have written this code. So it would be similar to the circular queue data structure, the same things which we will write them again, but yeah, operations will be same, just a little bit of tweaking with the same. Okay, so let's begin. I would say that we have 3.js. Inside this, I'll be writing circular queue. Okay, so we'll be writing code for circular queue. So first of all, here you can see that we have created a class. So I'll just create a class out of it and I'll just name it as circular queue. Fine. So this is my class name, suppose, and inside this I can write anything. So here you can see that they have initially we need to declare a constructor. So in our constructor, what are the things? Initially the array will be empty, and again also we need to actually, you can actually decide the full capacity and the length of your items. Like initially there will be no items, so you would say your items will be 0, no items, but your capacity can be 5, 10, 15, 20, whatever is the length of the array. Okay, I hope you are getting this. Whatever is the length of your memory, this is the capacity. And what is the length of your array? It's length of items. It actually means that what items you have in your array. Okay, if you have 2 items, your uh, length of items will be actually 2. But if I talk about full capacity can be anything, 5, 10, 20, 30, anything. Okay, so we'll be declaring things like that. And let's begin with writing the constructor here. Okay, so I'll just say that let's write the constructor, and I would say that constructor, and yeah, the user would initially say that whatever is the capacity, whatever is the capacity will be declared by the user. 5, 10, whatever is the memory unit is declared by the user. Okay, we can't use the JavaScript logic that array can be increased again and again. No, we are trying to save the memory. Okay, so the memory will be decided by the user. Okay, they can allot us a basic amount of memory, and the memory won't be increased. Okay, because we are using a circular queue data structure, we have to revolve things again and again. All right, so we have created a capacity here, and I would say that initially you can actually say this dot items, we'll be creating a new array out of it, and I'll just say new array will be having the same capacity. Okay, suppose the capacity is 5, we assume that the capacity is 5. Okay, so I would say capacity is 5. Fine, so it will be actually creating an array of capacity 5. All right, so now the array has been created. Also, we would say that the capacity of this array will be the values. The maximum elements can be which can be filled is actually 5. Okay, so the capacity will become 5. Now what would happen is this dot current, you can say current item, current size, or current item. I would just say that current size equals to this. Okay, current size will be actually equal to 0. That simply means that you don't have any elements in your array. Okay, your max capacity is 5 elements, but you don't have any elements in your array, right? So it's 0. And now initially you need to decide that the front is actually pointing to -1, and similarly the rear is pointing to -1. Okay, so this is a very basic constructor which we have created. And now what we'll do is we can actually check that if the array is okay, so we can actually check that if this array is full. Okay, so for that we can simply type is full. All right, so inside this you can simply say that if the current size is actually equal to the capacity, then your array is full, right? So very basic thing here. You can simply say that if they are same, then your array is full. If current size is lesser than the capacity, then it's not full. Okay, it's like that. All right, so now what we would do is we'll simply say that is empty. So is empty simply means that if the current size is equal to 0, that means your array is empty, right? Your array is empty, you don't have any elements in your array. That's the size. Okay, so now we'll be performing the enqueue operation. Okay, so in enqueue operation, we'll first of all provide the element which we want to insert. Okay, we first of all perform the enqueue operation. So I would say that yeah, we need to add 10 to this array. Okay, we need to 10 to initially add 10 to this array. Okay, so now what we do, we simply check that if the array is not full. Okay, so we'll assume that right now initially before performing any addition, you would be having five spaces, right? Five spaces. So yeah, five spaces are actually here. You can see that we have five spaces here. That means the array is not full. So this condition, okay, I've actually written it like this. So this condition will be actually true. That means the array is not full. So this will be actually allowing us to add elements, And in the else case, you can simply say, you can return that queue is full or something like that. Okay, I hope you're understanding this. So if queue is not full, that means you have space. You can simply say that increment the rear. Okay, increment the rear. Okay, this is the condition. This equals increment the rear. This dot rear plus 1. That's it. We are going to increment the rear like this. That's it. Okay, that's it. Now we are incrementing the rear, and what else, what did I told you is, first of all, you'll also add that specific value. Okay, so where you will add the value, suppose the rear's value now became 0. Rear's value now will become 0. So what would happen is, you'll simply add the value at 0th index, right? You'll add the value at 0th index. So it actually depends on the value of rear. Suppose the rear's value now is, in the next time when you try to add the value, rear's value will actually become 1. So you will be adding that element in the first index, right? So you would simply say that this dot items, I want to simply find that index. Whatever is the index of rear, whatever is the value of rear will be the index of the items array. You will simply add that element to that specific index. That's it. Okay, so it simply means that. All right, so we have added the element. One more thing, your current size will actually increment. Okay, your current size will actually increment. So here you would simply say that this dot current size is actually incremented by 1. Okay, that's it. Now what else? I told you that if front size is 0, front size is -1, then you can make it 0. Okay, that you can actually make it 0, or you can make it uh, equal to rear. Okay, equal to rear. Okay, both the case mean the same. But yeah, if you are assuming the array starting from the 0th index, then you can simply say that if this dot front is actually equal to -1, you can make it 0. You can just increment it to 0. That's it. Okay, that's it. So this is a very basic operation which we have performed for enqueue. Okay, now we'll be performing the dequeue operation. Dequeue operation. So here what we do is, we will simply say that we need to perform the dequeue operation. So in dequeue operation, we would simply say that if suppose the array is, while performing dequeue, you need to check that if the array is becoming empty. Okay, if the array is becoming empty, if it became empty, now what do we need to do is, if it became empty, you can simply say that queue is empty, or you can return null. Okay, both will work. So if the queue is empty, you can't perform dequeue operation on an empty queue. Okay, so if it's empty, you will simply return queue is empty. Now if it's not empty, there will be the else case. There will be the else case. Fine. So inside else case, you would simply say that, first of all, you can do one thing. You need to find the first element. You need to find the first element. First element can be found by what? Found by the front. I told you, whatever the element is going to be removed, which element is going to be removed, will be actually having the pointer front. Okay, so I would simply say that here you need to find the item which we need to remove. Okay, so it's simply at the front. Okay, whatever is the index of front, whatever is the value of front, will be actually the value inside the items which we are going to remove. Okay, so now we got the value which we want to remove. Okay, so we'd simply say that just make it null. Just make it null. Whatever was the index, just make it null. Okay, so at that position, suppose the front index was actually 3. So at the third index of items array, things will become null. Okay, if anything was there, it will become null. Okay, so now if we have it null, what I told you is, we also need to increment the front whenever we are dequeuing. Okay, now what else do we need is, we'll simply decrement the current size, because the size of this uh, size of the items is decreased. Capacity is still the same, but size is decreased, right? So we'll decrease it. Okay, and I will also check that if You can actually do one more thing. If this is empty, you can simply make them -1. Okay, if this array is empty, you can simply make them -1. So the next time you add values, they start from 0. Okay, right? So if they become empty in some case, you will start from -1, -1, right? And what else can you do is you can actually return the item also which we have removed. Okay, which we have removed. So you can actually return that also. Fine. So this is a very basic case for that. And one more thing, uh, I forgot to tell you that when whenever you are incrementing the rear, you are actually saying that if it becomes current length -1, then I am simply saying that rear becomes 0. Rear becomes 0. Same, whenever you are incrementing the front, it will reach the maximum value sometimes, right? It will reach at 4. What after 4? What must happen after 4? Front must become 0. Okay, so same condition is actually applicable to front. Same condition is actually applicable to front. So here you would simply say that I need to write a condition where if while incrementing front, like you need to perform it this way. You can say that we are doing it this way. So you can simply say that if suppose front's value is 4, front's value is 4, f is pointing at 4 before that, before this operation, before dequeue, front is pointing at 4. Now we are trying to perform dequeue operation. What would happen is we'll check that if it's pointing at the last value, that is front equals air dot length -1. Okay, so what must happen is you would simply say that front equals 0, or you can make the front whatever value you want. Okay, front equals 0. Okay, but in array case you will make it 0. All right, so because the 0th index is the starting index, so you'll just make it as 0, front equals 0. And in else case you would simply increment front. Okay, so you would say that else just increment front as it is. So this is the condition. Okay, so I hope you got this. So we'll be applying the same logic there, but here you can actually see that instead of writing both condition, you can see that we would simply say that here we have actually got a shortcut. So suppose if I give you an example, instead of these two, suppose instead of these two, I would just say that suppose we have front as -1 and the capacity is 5. So here you can see that we will first of all increment. We are talking about dequeue operation. So in dequeue we are going to increment front. So front will actually become what? Front will become 0. Okay, and what we'll do is we'll divide this by 5. We'll divide this by 5. So we'll simply check that if the division is giving remainder greater than 5, so we'll subtract it by 5. Okay, so we'll simply say we'll always return the remainder. Or it's like that. So here you can see that the remainder is 0. Okay, so I'll just remove this 5. So again you can see that if I talk about 1, again 5, so you can see that the remainder will again be 0, again be 1. Okay, so again for 2 it's still the same, the remainder will be 2. And if I talk about 3, it's the same, remainder will be 3. Okay, again if I talk about 4, remainder will be 4. But after 4, you can see after 4, if I try to increment the front, what will be returned? You can see 5 ones are 5 and 0 will be returned. So again I reached the 0th index. Okay, again I reached the 0 index. So that will be the condition. You would simply say that return that value. I'll just say that front first of all we'll just increase the front by 1. Okay, and then we'll give the remainder of this with the capacity, with the full capacity. Okay, so I simply mean that whatever is the incremented value, I'll just get the remainder. If the remainder is 0, 0 will be returned, 1 will be returned. It's like that. Okay, so I hope you're getting this. And similar logic is for the rear. We'll just say that whenever we are enqueuing, we are actually incrementing the rare, and then once rare reaches 4, we want to make it 0. Okay, right? So rare is simply performing the same logic. So I would say that rare percent capacity will be returned. Okay, so we can actually use this logic. So what I would say that here in our code, we need to just make a change. In the enqueue part, you can see that we are actually incrementing the rare part. But what if the rare reaches last index, that is 4? Then we simply say that instead of this, we are going to return the remainder. Okay, so the remainder is, if the rare is pointing at 1, remainder will be 1, then 2, then 3, then 4. After 4, when this value becomes 5, 4 plus 1, 5. 5 divided by 5 will simply return 0. So now rare will become 0. Okay, I hope you are getting this. So that's how you can change the front also. So you will again change the front here. Okay, so that's how you can perform enqueue and dequeue operation very easily, very easy. Okay, so this is a very basic example. And then if you want to print the value, or you want to peak value simply means that you want to get the top value, that means the front value. Okay, whatever is going to be removed, you can simply return the value. It's like the same. You can see that we have actually performed the peak value on the 0th index. Similarly, we are performing the peak value on the front, whatever is the front. It's not the 0th index, it's whatever can be the front. Okay, front can be pointing wherever I told you in the example. So that's how you can perform the peak operation. Then we have a lot of different operation. Let's perform the print operation. If you try to print this queue, what would happen is you would just say that simply print the array. Okay, simply print the array. So you can actually return this dot items dot to string. So I will simply print the array. Okay, so let's try to run this. We'll just create an example here. Okay, so here what I would say is, let's create a queue. Okay, my circular queue, it's actually my circular queue. Okay, fine. And then I would add 10, 20, 30, 40, 50, 60, one more, and 70. Okay, so you can see that I have added 70. Okay, I have tried to add 70, and let's see what actually happens here. So let's try to print the queue first of all. So let's see all elements will be added or not. So if I try to run this, you can see only 5 elements are added, because the size max capacity is 5, right? So not more than 5 can be added. But if I try to dequeue something, if I dequeue something, okay, so let's try to perform dequeue operation. What I would say is my circular queue dot dequeue. Okay, so now let's try to again cut this. Okay, now what I would do is I'll just cut this, and I have performed dequeue once. Okay, right? So what would happen is you can actually add one value at least. Okay, one value. Okay, so at most you can add one value. So if I try to run this, you can see that okay, I actually need to print this after. Okay, so I'll just copy this and I will paste it here. Okay, fine. So now if I try to run this, you can actually see that dequeue operation isn't really performed. Okay, dequeue operation isn't performed well. So let's try to check what happened with dequeue. So with dequeue, what one thing which we needed to do is whatever is the front. Okay, we actually did a mistake here. So you can see that whatever is the front will, okay, we got that value. We simply made that value null, fine, and then we decrease the current size, fine. And then I said that, yeah, it's actually fine. What's the problem here? Let's try to get this. What's the problem here? Okay, I'm actually performing dequeue operation. This dot items. Okay, fine, fine, fine. Then we are simply returning the item. Fine. Okay, let's try to run this. I think now it must work. So we have till 50 here. But what is actually removed? Okay, let's try to look here, and we are actually returning the all the items. We all the items in this case. So here you can see that, okay, for the dequeue, okay, yeah, actually we did a mistake, I think. We can do one thing. If I just console log it, would be better. Okay, so let's try to run this. Now you can see that I got 10 here. Okay, I got 10 here. So now if I try to print this, okay, one mistake which I did. So now you can see that I am getting 20. Okay, don't worry about these commas because we are actually printing things that way. Okay, you can actually see that we are printing things that way. We are actually converting it to string, then we are removing things like that way. Okay, so yeah, you can see that yeah, 10 is actually removed. And now if I try to add something, if I just copy this, and now if I try to add something, like suppose if I try to add 60. Okay, you can actually also print the values of front and rear if you want. So I'll just say get front and rear. Okay, so you can actually print the values of front and rear, so you will get both the values. Okay, and actually we can do one thing. We can say that the front is actually pointing to this value, and similarly rear is pointing to this value. Okay, so this is the better way for showing things. So let's try to uh, call this. So we have performed the enqueue, and let's try to first of all run this. Okay, so we'll just again run this. So now you can actually see that now instead of adding 60 in the last, can see 60 is added in the front. Okay, but now it's not actually about the front. The front pointer is now pointing at 20, but 60 is actually added to the 0th index. Okay, I mean that. All right, so now let's try to get the values. What I'll do is console.log and my circular queue dot get front and rear. Okay, I hope it works. So let's try to run this. You can see that the front is actually pointing at index 1, rear is pointing at index 0. Okay, so now if I again add something, if I try to add something, if I try to add 70 there, what must happen is rear will be pointing towards 70. Okay, towards 70, but it must be there, the space must be there, you can't add it like that. So first of all, let's perform dequeue. So what I would do is I would just say that let's perform the dequeue operation. Okay, let's perform the dequeue operation here. Now let's try to again get the front and rear. Okay, and you can also print the queue if you want. Okay, so let's try this again. All right, so if I again run this, you can see what happened here is what we did was, first of all, we got the whole. Okay, then we dequeued. That means we simply removed the value 10. Okay, 10 is actually removed, so our array looks like this. Now we added 60, so 60 is actually added to the position of 10. Okay, to the position of 10, that is 60 is added here. Then you can see the same old array, but now the front has become 20 and the rear has become 60. Okay, so rear has become 60. Okay, before adding 60, the rear was actually at 50. Now it became 60, right? Right, you can see I printed those values. Now again, if I perform the dequeue operation, what will be removed? Whatever is in the front will be removed, that is 20 will be removed. Okay, 20 will be removed, front was pointing at 20, so 20 is removed. Now you can see again I've got these values because once I add 70, 70 will be added to the position of what? Position of the last front, whatever was the last front will be actually taken. Okay, so you can see that 70 took its position. Okay, whatever was the empty position, and you can say that after rear we actually enqueued. So what would happen is now rear became 70 and the rear's value is 70. You can see that the rear is pointing at 1 and its value is 70. And also now front has incremented to 2. That means front is pointing at 30 and its value is 30. So the next time 30 will be removed, and next time if I add value, rear will become 2 and value will become whatever value add, suppose 80. So value will become 80. So it's like that. So this is a very basic operation, but yeah, it can be actually used to save a lot of memory. You can see that we are saving memory, although it has some restriction. That means obviously if you are having restrictions of memory, you can't add actually things after some time. Like I have limitation of 5 blocks, so I can't add more things if I don't have empty spaces, right? I hope you're getting this. So this is a very basic operation which we have performed today, and that's it for the circular queue data structure. You won't be needing to learn anything after this, and if you try to learn, if you try to implement it's same, the same logic in some other language, C++, you would find it same. Okay, you would find it same. So it's very same logic, but yeah, code is easier in JavaScript. Alright, so I hope you understood this video. If you have any doubts, you can ask me on the live chat, or you can message on any of my videos. I'm always available. Okay, I'm always live also. So we'll always go live every day for different kind of topics. And in the next video, we'll be bringing more topics on data structures. Alright, so before ending this video, in the description or in the live chat, you'll find a link of a course provided by Geeks for Geeks. So if you visit that link, it will take you to this page. Okay, so it's a paid course, so if you want to learn DSA in JavaScript, you can actually buy this course. Alright, so you can also see the course content which is available here. So if you want to learn DSA in some easy language like JavaScript, or if you want to learn DSA for web development, you can actually go for this course. Alright, so you can see that everything is covered here. So if you are trying to switch to some other language after learning this DSA course in JavaScript, you won't face any problem because everything is same, almost same. Okay, and all the algorithms are also taught here, so you can check this one from basics to advanced level. Okay, so that's it for today. I will see you in the next one. Till then, see you. Have a good day. Bye bye.